Hello everyone. So in this video, we'll discuss about these linearity of these two circuits. Okay, so this problem was mainly to understand what is the linearity and how we can analyze these circuits in terms of linearity. And the second question says about driving capability of the circuit. So these terms, first we'll understand what are these and how to implement the concept of linearity, what we will learn after some time, and how to see and what to see in this circuit so that we can say the particular circuit has the better current driving capability. So the technicalities of these terms, linearity and current driving capability, will be the main concern of this video. So we will proceed first the linearity, then this current driving capability, and what this RC circuit is doing here. Because my third question is the condition on the RC circuit, or or we have to tell something about in terms of RC time constant, so that the second circuit has some specific operation. So first we will proceed this lecture like first we will understand the what the linearity is. Okay, so first thing is what is linearity. What is linearity? Okay, so from just a graph point of view, we knows that any quantity which directly depends on the quantity x, the y directly depends on particular quantity x. This relationship is called the linear relationship. This is called linear relationship. Okay, so it may like with some intercept, then this is my y, x. Here y can be mx plus c, where c is the intercept, equal to a linear relationship. Linear relationship, but with offset, or can say offset is there. That I recall what is the offset. I discussed this term because in terms of analog electronics, we will see this term frequently. That's why I call it offset. Whether in mathematics is called the intercept. Okay, so this is just a mathematical overview. If in terms of the analog electronics, what linearity is. So we say if there is any block, which I call the block called GM block, it can be the block like amplifier block. So what we have seen till date, if there is some transconductance block having the inputs V1, V2, it will generate a current I, which is nothing but GM time this difference voltage, that is V1 minus V2. So what is this? This actually is showing the relation. The I is a function of your V in, which is called V differential, V1 minus V2. So this relation is a linear relation. So I can say the I is a linear function of input voltage V1 minus V2. Okay, so this way we can see. And the second thing, there is a suppose a block consists a gain element A inside it. What do you call the V out? The V out is nothing but A times V1 comma or V1 minus V2. This is, I will say that V out is linearly dependent on input voltage or difference voltage. Okay, input voltage or difference voltage. So it can be said that whether I have a I is a function of some V input, whether I have a V out is a function of input voltage. So if these are the linear functions of input, So this thing we see in any GM block that I have discussed in previous CTQs. Any GM block which takes the input V1 V2 and convert it to the current, which I call GM V1 minus V2, and this current goes to some capacitor that we have seen. It is nothing but a job of a 5 transistor OTA. So here what is the output voltage? It is nothing but 1 upon CL integration of GM V1 minus V2 dt. So we all consider these relations as just a linear relation. So here the consideration is that all the quantities output quantities of any particular block, whether it is a GM block or it is a gain block, or it is a gain block, the output is directly dependent on input with some linear function that we call a v1 minus v2. So output is the linear function of input. Is this always correct? Now point comes, I can write the usually a block is written like this, so no need to confuse, same thing. Okay, so the point is that, is this correct always? Is this relationship correct always? Okay, so now point comes, is this relationship is true always? No, because what is this? The answer is no. Because the MOSFET is a non-linear device. What the current we see usually in the MOSFET, because we are dealing everything in terms of the device which is an already non-linear device. MOSFET is a non-linear device. So whatever the equation of current that we write, it is some in saturation region. Suppose K and S by 2, if I am writing for the NMOS, WIL VGS minus VTH whole square 1 plus lambda VDS. For a time being, if I ignore this relationship with this VDS, then also I can write this K and S by 2 WIL this VGS minus VTH square. So if I consider this gate to source voltage is the input voltage of my transistor, then we can see that what we can see, if this is my gate to source voltage VGS, and if it is varying, what we can see, this current ID is a function of course VGS, but it is a non-linear function. What is the problem in this? Actually, if my ID is directly relating to this input, like as a function of input voltage with the linear relationship, then we can think it as a like we can use it as an amplifier, because then we can predict what linear relationship with the input my current has, and accordingly that current can be converted into the voltage, so that we can find the output voltage which is linearly dependent on the input. So if there is a non-linearity, then we cannot say what is the dependence of the output on the input. So the amplifier is some linear device. So if this is a linear, then it is good. So the motivation of amplifier comes from here. Motivation of amplifier comes in like, it takes the input and convert it to the output. Whether it is a current or voltage. If it is a current, it is converted to the voltage using some current to voltage converter, that is a resistor load, current or voltage. So better the amplifier is when this relationship is linear. That's why we are concerned about this relationship. So better the amplifier is if this relationship is. So now the point remain as a homework for you. what is the problem? Homework. What is the problem if relationship is non-linear? If relationship is non-linear, who is stopping you? Okay, so I will not write this point. I can see. Okay, so what is the problem if relationship is non-linear? Cannot be it used in your amplifier, cannot be designed or amplifier if the relationship of the output current whatever is a non-linear function. Why we not accept this as it is and we can design our like amplifier? What the problem? You have to see this. Okay, so now point comes. So if there is a device, we can see from the characteristics. Now I'll go fast. In general, this is the input to output characteristic of an amplifier or any transistor VGS. That this is the current is a nonlinear function of the input. This is a nonlinear function of VGS. Okay, so we can see at every point the current has different relationship with the input. So no, we cannot predict it. At this point, the slope is less. At this point, slope is different. At this point, slope is different. So slopes are different at this point. Slopes are different. So what we are understanding from the slopes? Actually, the slope is nothing but the slope is del ID by del VGS, which we call 1 upon R, that I call resistance, or I can say R out. I should not say R out. Better to say this relationship is inversely proportional to some resistance. Better to call it because the current is output and this voltage is input. So better to say some transconductance parameter, which I call Rm, or I will say it as Gm. So this is the means current conversion capacity. I can say conversion capacity, current conversion capacity or efficiency of a transistor, efficiency of transistor. So you will get your answer why we are asking or why we are looking for the linearity. You will see that. So what our MOSFET is doing, the job of the MOSFET is to take the input that is called VGS and convert it to some output that is called the ID, which is depending on this GM Vin. Okay, so actually the current that we are getting at output is nothing relating with the GM, relating with the input using some parameter called GM. So this is the same relationship that I was getting for some block. There is a, if this is my 0 and here I applied V in, so this difference times this current is nothing but GM V in. So it is something like that. So what we are getting from here, the relation, we can get some the amplifiers that we are designing, the 5 transistor OTA, whether it is a voltage amplifier. The idea is simply that. So the better, stronger the GM, stronger the GM, better is current conversion, better is current conversion capacity, or it is good voltage to current converter. Okay, so this thing I will relate little bit about the from the BJT. If BJT is taking some input and is converting to the current that we call the IC, it is usually related to this input voltage sum in this fashion, which is the exponential fashion. So from this, if I calculate again this, it comes like I naught by eta Vt, that I call V in eta Vt. So I naught by eta Vt. Okay, not I naught, it is IC. So it is nothing but IC by eta Vt. So for particular note, for particular input voltage, BJT has better current conversion capacity. Input voltage to output current conversion capacity, because its output is exponentially dependent on the input. The output current is exponentially dependent on the input voltage. So we can say it is its GM is, in terms of say indirectly I will say that GM of BJT is usually strong or more than this MOS. So this is the one advantage of GM, means advantage of BJT over the MOSFET. That you can say it is a better current converter, means GM is good for BJT. But this point is not here. I have to discuss. The point is, what is the importance of linearity here? Okay, so we can see that all the relationship where we design that amplifier, we see in this entire characteristics, we are not everywhere biasing our circuit. We are biasing to a particular point, and around that point we will see that we look for the linearity where the slope is maximum. In that reason we always want to bias our circuit, and so that we can have the better the GM there. Okay, so this particular region is looking linear. It is a looking linear region. Looking linear region. What we do in just in amplifiers, we bias our amplifier somewhere here, and we remain such that in this region, if my input is applied like this, a small input is applied like this, what we can see from this characteristic, as the slope is maximum, the this big output can be obtained. Okay, so this is the basic concept of linearity, and why we are looking for the linearity. If my why I cannot apply a bit bigger sinusoid at the input. And here you can see what is the problem with linearity. If I am applying bit bigger sinusoid here, what you can see is for particular value of sinusoid input, this is my current, and for other value of the input, the value of current is very larger. So what we can see here, okay, so what we can see here, what output I am getting, this is a different current. Suppose I call it I1 and this is a I2 I should call. So I2 del I2 by del V in around the I1. This del Iy, not I1, del Iy del V in around I1 is different. Is different from del Iy del V in around I2. So what will happen? So actually this sinusoid that we are getting at this point is not exactly at this point. So this region, this much linear that we are considering here for the amplification is a part of nonlinear curve. It entirely is a part of nonlinear curve. So what can be seen that if your output is exactly sinusoid, if your output is exactly sinusoid, what is the problem? Problem of nonlinearity is output may not have same characteristic that of input. Let's see. Okay, so now I am directly going to the amplifier. If there is an amplifier, it is its input, it is its output, V out. So if my A is a linear function, this amplifier is linear. Okay, so A is a linear, then what I can say, I can directly rate A as a times of V in. Okay, suppose my this amplifier is a nonlinear function. Amplifier has nonlinear function of input. I call it nonlinear function of input. So what I can obtain if I am feeding the input as am sine omega mt, if my output is a function like, if my amplifier function is like that, amplifier is a function of input such that it can have v in and v in square terms, then what you can see the problem of nonlinearity here. So the output will be what? V out will be a v in plus a v in square. Okay, so I can say a am sine omega mt plus a am square sine omega square mt. Okay, so what do you see here? A am sine omega mt plus a am square 1 minus cos 2 omega mt by 2. I think this relation, check it once. I am not sure it is correct. Okay, what we can see, I am giving the input of V in has the tone of FM only, but what V out can have the tone like FM, DC voltage, sorry, DC frequency or the DC signal, FM, and also 2FM. So the same way, what we want to get, we actually want, the target is that, target of amplifier is whatever the input, if this is the input, simply better to say am sine omega t. What is my target? I want the output which is amplified version. I want the output which is amplified version of my input. I only want change in the amplitude, is nothing but am sine omega mt. Maximum thing that I can accept is some phi, not more than that, anything. So this is my output amplitude bit I call a out sine omega mt minus phi. The phi can come, but the nature of signal should not be changed. The tone that I want should not be changed. The tone is still my FM. This is my amplified output. This is my amplified output. Okay, so we can see what is the problem with this. Actually, whenever we are sending some signal with the AM here, this is 2 AM peak to peak, in some particular block I want a signal out here which is nothing but 2 AM. Okay, so peak to peak is twice. So this can be simply your mobile phone. This can be simply a mobile phone which is nothing but amplifying the signal, or any amplifier. It can be any amplifier which is just taking the signal. It is taking the signal and amplifying it. So we only want the amplified output. So amplitude should be high. Amplitude should be high, not frequency disturbance. What is frequency disturbance? Frequency disturbance simply nothing but an unwanted signal. Because I am sending the input at FM, I would like to get the output with the FM only. If there is any other tone, then it is totally of no use for me. Because whatever the operations we do, any other tone like a DC can be filtered, it can be filtered, but any other tone, let the 2FM, 3FM, any higher FM, NFM, they are unwanted. Because what operation we want at FM only. So all other frequency components are unwanted for me. Whether they are amplified, I don't care about that. My point is that if I am sending particular signal to my through my mobile phone, through my amplifier, then this particular tone should be amplified. I am not worried about that it is giving me the higher frequencies or that. This is not my requirement. So it is totally the wastage of the signal. So what we can understand, if someone of you are known in the frequency domain, our sinusoid is what? Our sinusoid of particular frequency is a single tone. So this is a single tone. That is the frequency of my sinusoid required. So this is the A is the amplitude that I am not mentioning here. So now what we see when we do the DFT analysis, in DFT analysis I will mention here DFT analysis, you can see this thing. So this is my main sinusoid tone. This is the sinusoid tone that is required, and any tone apart from it, either its amplitude should be very low or it should be negligible. If due to the system nonlinearity the second tone is coming, that can be of 2f, it can be of 3f and further other f's. So it can be my 2fm, it can be my 3fm, it can be any nfm. So if your system can reject all other frequency components which are not desired as a better system, and even they are coming, then there should be some limit. This is my fundamental component and this is my second harmonic. So this particular gap is known as HD2, and that is called the harmonic distortion. So if this amplitude is A, this is B, so I will say simply A by B, or not A by B, that I will say B by A is a harmonic distortion. So B by A is harmonic distortion 2. So the second harmonic, so this H2, this is in dB, okay. So this value or the second harmonics, that is unwanted frequency of 2m, 3fm and other fm, they should be much suppressed. So if we can avoid, it is better to avoid, otherwise they can be suppressed. Better to avoid any higher harmonic. If it is not possible due to the system problem, due to the system non-linearity, then it can be suppressed, and it can be suppressed up to a good extent. That is a requirement of every system, what we design, how much the second harmonic should be suppressed. Okay, so okay, this is my okay. So what we can see here, what the nonlinearity and how exactly these higher harmonics will suffer your signal. So if my sinusoid, that is the input is very smooth sinusoid, and at the output it may possible, if it is passing through some nonlinear block, this I call nonlinear block, then what I expect at output will not be there. Suppose there may be some clipping, so such kind of nature of output is not expected. So this is called clipping. It is not expected, non-acceptable phenomenon. So no one will want that. If you are giving a proper sinusoid, no one want this particular kind of input output. So that I also can say this is unwanted frequency components. This is my unwanted signal. It is of no use, and this particular clipping area cause because of some higher harmonics are there. So it has some higher harmonics, higher frequency components are in it. Okay, so this is of no use. So we can see here the disadvantage. What is the problem of nonlinearity? So nonlinearity causes problem. That problem we have seen. Whether our output will be of a different shape, it will have some clipping kind of behavior, it may have some peaks. So what exactly the input is sinusoid, exact input is my sinusoid, and output should also be sinusoid of that particular frequency with amplified output if it is my amplifier. Okay, otherwise everything is waste of effort. So what we can see linearity or the higher harmonics, if any one of you is aware, this particular signal, what is this? This is my pulse signal. What is actually the pulse? The pulse is nothing but a combination of infinite frequency sinusoids. Combination of infinite frequency sinusoids. Sinusoids. So it has all the components of sine from DC to FM to FM and NFM. So this depends on a particular shape of this pulse. You can see all the components are here. So any particular clipping happening in your sinusoid, it means there is an insertion of some higher harmonics, which is actually not desired. If my input is sinusoid for the amplifier, then it is a non-desired phenomena. That's why non-linearity is of no use. It should be suppressed properly. Okay. So any other thing that you can see about the non-linearity, I can recommend something, but later we'll especially go inside this circuit. Till then, I'll recap what I told you about, or I can say, if you see the Fourier series expansion of this Fourier series expansion of this particular signal, then you will see that there are all frequency component inside the pulse. So any shape which is changed not from the sinusoid, which is not exactly the sinusoid shape, there can be the higher harmonics, which are of no use. The higher harmonics is simpler things when you are calling and there is some other frequencies received on the receiver side, then it is totally the disturbance. It is an unwanted signal. Okay. So I can recap here what I told in this. Okay, so these were the basic two circuits that are supposed to be explained in this lecture, but actually I could not take because of the linearity concept in detail, and what the current driving capability I'll take with this circuit only. Okay, so what the concept of linearity I tried to give the idea, and after that what exactly the relationship of current of MOSFET on its input voltage and how it can be understood in better way, and how it is related with particular input that depends on the GM of this device. So depending on the GM, we can say that what the current conversion capacity of particular transistor, particular device, the BJT is better in that. So this is overall just basic that you can see from here, and it is not required. And in the non-linearity, you can see here the actually we select only a particular reason for the amplification that is actually considered the linear reason. This is the importance of linearity. If there is a particular non-linear current that we are using for the output, because what we are getting, we are converging our voltage that we are giving to the particular transistor to the output, and if this current is non-linear function of the input, then what will happen? The same thing, the higher harmonics will be entered into this output, which are of no use. Okay, so if I am giving a particular feeding input of some particular frequency of FM, and if I am getting the output of the higher frequencies, it may be the square dependence, cubic dependence of output on the input, input q, input power 4, power 5 and higher powers, then we will have the lot more components of the frequency in the output, means which are non desired, which are not required actually, because we are feeding the input of the FM tone, then we are expecting out of the amplifier we should have the signal of FM tone only with the amplified output. Only the amplitude will be changed, maybe the phase can be set, or it can be delayed, or somehow it can be early signal depending on the phase. The phase is inserted by the signal. So all the systems that we analyze actually are the linear system. So all the systems that we want to analyze are all systems like in analog, whatever the amplifier and all systems we like to be linear systems only. Linear system. Usually we have seen this thing in the control system detail. Always we talk about LTI systems. Why we called LTI system? Always because the LTI system are useful when we convert any particular input to any particular output. Then what we will see, this relationship should be linear. The relationship should be linear, whether it is amplifier or whatever it is. I told already much about it, and you can learn something. If you want, you can follow a particular book that I can say Alan Hallberg to see this concept in maybe more detail, but it is enough for you to get an insight of linearity. Later we will see these circuits and compare these two circuits. So I think this is enough for this video. Thank you.